Okay, so here is a very nice example of how we're going to be calculating unbiased estimate of the population variance and so on. So a random sample of 14 sacks of potatoes are weighed in kilograms, and the results are as follows. We've got 9.8, 10.1, 10.2, and so on until 10.2. We need to calculate 2 decimal places an unbiased estimate for the mean weight of the sacks. Okay, so unbiased estimate of the mean weight of the sacks is going to be the sum of all of that divided by the sample size. Sample size, we've got 14 of them here. So solution is just like, you're calculating just the mean, basically. So summation of x, and if you were to add all these up, you'll get 141. Therefore, the unbiased estimate of the mean weight of the sacks is going to be equal to 141 divided by 14, and to 2 decimal places we're looking at 10.07. I guess that was pretty much easy. And the second one, we need to find the variance of the weights of the sacks. Now for the variance of the weight of the sacks, you will remember I told you my favorite one is this, n over n minus 1 into the summation of x squared over n minus the mean bar to the square. So what about summation of x squared? I'll leave that up to you to calculate the summation of x squared, which is very easy. So basically what you do, you square each of these terms. Like, for instance, you got 9.8, so you're going to go for 9.8 to the square plus 10.1 to the square plus 10.2 to the square, blah blah blah, and so on until you come here. And when you add up all of that, you should be able to get 1420.58. So we're going to be using this over here, and basically, so what we have is now n, which is the sample size, over n minus 1, that is 13, because 14 minus 1 is 13, and all of that multiplied by the summation of x squared divided by n. We did calculate the summation of x squared, and it was 1420.58 over the sample size 14 minus the mean unbiased mean to the square. And if you do all of that from the calculator, you'll get something like this, times 0.065, and this all comes to 0.07. So that's my unbiased estimate of the variance of the weights. Well, so here we are. So that's the second part of the question done. And for the third part, which is the easiest of all, proportion of the weights that is less than proportion of weights less than 10 kilograms in the sample. We've got 5 of them, and that's going to be divided by 14, comes to 0.36. Check. There's 1, 2, 3, 4, 5. These 5, they are less than 10 kilograms. Well, I hope you've been able to get some understanding of how we go about and use these formula to calculate these points of estimates. Okay, take care.